Go language programming, Chapter 8, Unit 4. In this unit, we will cover JSON and Go language, string format of JSON, stream format for JSON. So let's start. JSON package, Go language package JSON implements the encoding and decoding of JSON as defined in RFC 7159. So, all the specs are in this RFC for the JSON. To interact with different technology, it is required to do data exchange. So, as we are basically around the world, we are involved in many different types of technology, and every different type of technology has a different kind of a data coming out of it. So basically, it is really required that the data exchange occurs between two different technologies in such a way that there is no loss of data. Okay, and for that reason, JSON was basically developed. So data exchange is a process to convert source data into the format that the receiver can understand. So that's the whole objective about JSON as well. So two systems can understand each other's. So Go language uses JSON for the purpose of data exchange and provides the extensive API. So Go language has a JSON package, and that package provides many different APIs. So JSON can be used in the Go applications. All struct fields should start with uppercase, so they are exported, which we already have discussed, and we already know that if the struct fields need to be able to accessed from other packages, then they must be exported, or the first character should be a capital of the struct fields. Only the exported fields of a struct will be present in a JSON output. So when the JSON will output its data, then it will only be using the exported fields. So data structures that represent a valid JSON will be encoded. So basically, so the one that doesn't have a valid JSON, then definitely it cannot be encoded. So the syntax of JSON is very important, the one that we discussed in the previous unit. . JSON object only supports strings as keys. Map type must be a form of map, a string. So that's the main point that you need to remember, that um, it will only support the strings as keys in the map. So and then this type could be any other type, but this the keys must be of string type. Channels, complex, and function types cannot be encoded. So basically, they cannot be represented in a JSON format. Cyclic data structures are not supported. Okay, so that's another issue with JSON. It doesn't have a capability of supporting any cyclic data structures. So they will cause Marshall. Marshall is the function in the package, JSON package, to go into an infinite loop. Pointers will be encoded as a value they point to. Okay, so pointers are okay, they will be encoded, or null if the pointer is nil. So it's possible that pointer might be a nil pointer, so it will be considered as a null for JSON. Now, some terms that are used in Go language with the JSON are this Marshall. Okay, Marshall means to encode a Go language values to JSON format in a string format. Okay, that's what the Marshall will do. Unmarshall meaning to decode the JSON string data to Go values. Encoding is same as Marshall, but it is used for streams. Okay, stream is nothing but a flow of um, bytes in one direction. Just like a stream of water. Water flows only in one direction. Decoding, same as unmarshal, but in the form of a stream. Okay, so for decoding of string and decoding and encoding of streams, there are two different methods that are provided in Go language, and we will see it in the examples coming soon. For any JSON format, string or stream, JSON standard library must be imported. Okay, so it doesn't matter if you're working with the strings or stream, you must import this package, standard library package encoding JSON. By default, basically, JSON supports for decoding and encoding. These are the types: Boolean for JSON booleans, float 64 for JSON numbers, string for JSON strings, nil for JSON null, array as JSON array, okay, map or struct as JSON objects. So these are the data types that are supported by JSON. Now let's look at the string format for JSON. Following functions support encoding and decoding of JSON strings. So the standard library package provides the marshal and unmarshal for decoding the JSON. Okay, so marshal will convert the Go struct into a JSON format. Okay, unmarshal will convert the JSON into a Go language format. So these are the two commonly used functions for the strings, not for the stream. So the prototype for marshal function is that the parameter it takes is of interface type, and it returns a slice of byte and then error. Unmarshal function takes slice of byte as the first parameter, and the second parameter it takes is a interface type, and it returns an error. So marshal function accepts an empty interface. The marshal function it will accept an empty interface and returns an array of bytes and error, like you see it right here. Unmarshal function accepts an array of bytes and an interface and returns an error message. So in this example 8-4, what we will see is that encoding or marshalling and decoding or unmarshalling of the data. Okay, to do that, of course, very first thing we have to do is to import this package, encoding JSON package. Okay, and then at line number 8, we create a struct of type employee, which has two fields in there: first name, first and the last. Okay, and they both are string type. So as you can see, they have the first character is uppercase. They are exported. Within the main function, we are creating an instance of employee, okay, and assigning the data to this instance. So that's all we are doing, assigning the data. Okay, so emp1 is a instance of type employee. And now we can marshal it by using a JSON marshal function. Okay, so marshal the JSON into a bytes. So this marshal function returns two two values, as we just discussed right here. Okay, so it returns the slice of byte and error. So in here, in this marshal, we are basically ignoring the error. We don't care about the error at this point. But this BS is a slice of bytes, a byte slice. And of course, the marshal takes the instance of this employee type, okay, which has already the data is initialized. So now it is going to marshal it. So when it marshals it, and when it comes to this print line, it will basically will print out the in a JSON format. Okay, and the reason that I'm typecasting this slice of byte is because to a string is because otherwise it would be just actual bytes will be displayed, and which would not make any sense. But this strings will convert this bytes into a strings, so we can see actual JSON format. And then at line number 20, we are creating a instance of employee type emp2. Okay, that's a separate instance. Now in this instance, what we want is to get this these bytes and give it to unmarshal. Okay, as you can see, the first parameter of unmarshal is taking the slice of bytes. Okay, and then the second parameter is of interface type. That means it could take any type right here. Okay, so in our case, we are passing the instance of this employee, so, and the address of that instance. So when we pass it, what this unmarshal will do, it will populate this instance with actual data, so it will be converted back into the strings. Okay, so this will be the strings that will be converted. This right here is, it will be displaying into the JSON format. So that's basically about it for this example. It is showing you that you can marshal the data and then you can unmarshal it. So marshaling meaning that you can convert the data into the JSON format, and unmarshaling meaning you can convert back into the string format. Okay. So let's now, so this was string format. Let's look at how this encoding and decoding is done in the streams format for JSON. So following function support encoding and decoding of a JSON streams. Okay, so in this case now, as you can see, these are the different function names. They are not marshal and unmarshal. So basically, but they are similar, but they are used for streams. So new, decoder, and decode. Okay, these are the functions that you can use. So in here, new decoder function takes the parameter of type IO reader, okay, and returns the pointer to a decoder, and encoder takes the parameter of type IO writer and returns the pointer to the encoder. So these are new encoder and new decoder are from the standard JSON package. So new decoder returns a new decoder that reads from the IO reader. Okay, that's what. So that's what we just discussed, right? Use the return decoder to call the decoder function and pass the stream data as parameter to decode the function. Okay, and we will see that in the example uh, uh, 8-5. So we use a new encoder and encode function. Okay, and in encoding basically works with a writer and writing streams of JSON data. So, this is what it works with. New encoder works with the writer. To encode JSON through a writer, Go language provides the following function. So this basically is not really a function. It's a method. Encode is a method, because it has a receiver right here. Okay, so it's a method, and this method takes one parameter of type interface, and it returns the error if anything goes wrong. Use the return encoder to call encode function and pass the interface type parameter to the encode function. So that is also, is in this example 8-5. So let's go and walk through this example 8-5. So in this example, very first thing we have to make sure that we import encoding JSON package, and then the other ones, the log is to basically, if any error occurs, we use the log package. OS is used for writing it on the display, and strings package is used for calling the new reader. Okay, so let's see how this body of main has a logic for converting the JSON um, stream. So we have a JSON stream right here. Is a key value, key value, key value. Okay. So basically, as you can see, this is all key value, and it's a stream. Okay, it's not a string. String is a stream, so it's a flow of these strings, in one direction, and we save it into this variable called JSON stream. Then we create a type of IO reader using the strings package, so that's why we have this imported package strings. So we use this strings package to call this new reader, and we give this new reader this stream. So now new reader will have the will return the string, and then we are saying that whatever uh, this JSON um, stream, once it is converted, we will use this standard out to display it back. So let's see, create a new decoder which reads the data from the reader. Okay, so that's what we are doing. We are um, calling this new decoder and read what we got it from the new reader. Okay, so we want to decode this this JSON. So DEC will have the new decoder. Now, basically, we are saying create a new encoder which writes the data to the writer. So, we know that we're going to be writing it to the standard out. So we are, giving this to encoder. That means letting the encoder know that write to the standard out. Okay, that's why we are passing this this OS dot standard out to new encoder. And we have a for loop right here and set to line number 38. So we are going in there, decode the arbitrary JSON in the map, and as we talked earlier, that this keys must be always be a string. Okay, and then right here, this type could be anything. So that's why we have an interface right here. So what we are doing right here, we are making a stream map. Okay, so we are creating a empty map right here. Okay, so make stream map. Now, then we are calling the decoder and we are passing the address of the map. Okay, so basically this what this is going to do is give, because we are using a DEC to call this decode method, it is going to pass that that string or that JSON to this decode method. Okay, and once this method decodes that this JSON, it will dump everything in this map. And if there is any error, as long as it's, if it is not a nil, that means there is an error, then it is going to come right here. Okay, if it is a nil, then it's not going to come inside this body and it will come out right here. So in here at line number 30, what we are doing is we are going through the map. Okay, we are going through, so we have a for range loop right here. So what we are doing right here is we are going through this make stream map. So each one is picked up from the map, and here what we are checking is if this key, so we are going to get a keys in here. K will hold the keys. So if the key is equals to age, we want to just delete that key, okay, from this map. So that's why we are using this delete function. Just This is just to show you, if you can, after decoding, you can basically you know remove some um, uh, key value pair from the map. And then once you have this, then here at line number 35, we are giving this make stream map to encode. Okay, so this will encode this string back to the JSON. Okay, so that's what this example basically does. And with that, we conclude Unit 4, Chapter 8.